In 1925, deep inside Tutankhamun's tomb, archaeologists found a dagger wrapped against the mummy's thigh. The blade was iron, and that was a problem. Egypt wouldn't smelt iron for centuries. For 90 years, the blade was a puzzle. Then, in 2016, researchers pointed an X-ray instrument at it and read its chemistry. 11% nickel, a trace of cobalt. That's not the fingerprint of anything mined on Earth. The pharaoh was buried with a blade forged from a meteorite. And that tells you something strange about the ancient world. 3,000 years ago, iron, the most common usable metal in the Earth's crust, was rarer than gold. This is the story of how humanity cracked it. But to understand why iron changed everything, you first have to understand the metal it replaced and the astonishing, fragile world that metal built. Bronze looks simple. Melt copper, add about 10% tin, and you get a metal harder than either. Good enough for swords, plows, armor, and empires. Copper is easy. It's found all over the ancient world. Tin is the problem. Tin is geologically scarce, and almost none of it exists where the great Bronze Age civilizations actually were. Egypt had no tin. Mesopotamia had no tin. Greece had almost none. The nearest big deposits were at the edges of the known world. Cornwall in Britain, the Ore Mountains of Central Europe, and far-off Central Asia. Which means every bronze sword in a pharaoh's armory contained an ingredient that had traveled farther than most people alive would ever travel. We know this because the ingots themselves testify. In 2019, researchers analyzed tin ingots recovered from Bronze Age shipwrecks off the coast of Israel. Isotope analysis, reading the geological birth certificate locked inside the metal, pointed to a most likely source 4,000 kilometers away, the tin mines of Cornwall in Britain. Think about what that means. Around 1200 BC, tin dug by miners in Britain, people who had never heard of Egypt, was crossing the entire European world to be melted into tools in the Levant. 3,000 years before container ships, bronze had built a global supply chain. If you want to see that supply chain in a single frame, look at the Uluburun shipwreck. Around 1320 BC, a trading vessel sank off the coast of Turkey carrying 10 tons of copper, a ton of tin, enough to make bronze for a small army, plus ebony from Africa, amber from the Baltic, ivory, glass, and goods from perhaps a dozen cultures. One ship, one cargo, half the ancient world on board. And here's the part I love. Scientists are still fighting about where its tin came from. A 2022 study traced about 2/3 of it to Turkey's Taurus Mountains, and, more surprisingly, the remaining third all the way to a mine in the mountains of Tajikistan. A rebuttal a year later said, "Not so fast. The method can't prove it." The candidates are thousands of kilometers apart, and the argument is happening right now, in journals, over ingots that spent 33 centuries underwater. Either way, the conclusion stands. Bronze made distant strangers depend on each other. That was its glory. It was also the trap. Around 1177 BC, the Bronze Age world fell apart, fast. In the space of a couple of generations, the Hittite Empire vanished. Mycenaean Greece collapsed into ruins. Ugarit, one of the richest trading cities on Earth, burned with unsent letters still baking in its archives. Egypt survived, barely, and never fully recovered. What happened? Honestly, we're not sure, and anyone who tells you otherwise is selling a book. The suspects include a brutal multi-decade drought, earthquakes, internal revolts, and the mysterious sea peoples who show up in Egyptian records as raiders from the sea. The best modern answer is probably several of these at once, cascading through a system too interconnected to absorb the shock. Because that was bronze's hidden weakness. A world that runs on tin from 4,000 kilometers away is a world that dies when the ships stop sailing. And here is where one leading theory picks up the story. With trade routes severed, tin, always scarce, always distant, stopped flowing. Smiths across the eastern Mediterranean faced a choice: find a new metal or stop being smiths. There was an alternative. It was ugly, it was stubborn, and it was quite literally everywhere. Iron ore, sitting in hillsides and riverbeds on every continent. There was just one problem. Nobody could really work it. Bronze is friendly. It melts at temperatures ancient kilns could reach, and it pours into molds like candle wax. Iron is not friendly. Ancient furnaces couldn't fully melt it. The best they got was a spongy, slag-riddled lump called a bloom, which had to be hammered, folded, and hammered again. And the first iron produced this way was often no better than good bronze. Softer, sometimes. And it rusted. So iron didn't win by being better. It won by being everywhere. Bronze was an aristocrat's metal. Its ingredients had to cross continents. Iron was a peasant's metal. The ore was in the hills behind your village. Once smiths learned the tricks, higher heat, charcoal chemistry, quenching, and above all adding carbon to make steel, the economics were unstoppable. A bronze sword was a nobleman's treasure. An iron sickle was a farmer's tool. That difference rearranged the world. Watch how differently the two metals moved. Bronze spread like a network, thin threads between palaces and ports, elite to elite. Iron spread like a wave. Anyone with ore, charcoal, and the know-how could join, no imperial trade fleet required. From Anatolia and the Levant, ironworking rolled through Greece and across Europe. The old textbook story says the Hittites guarded a jealous iron monopoly. Modern scholars largely doubt that. But the kernel of truth is that Anatolia was working iron early, and after the collapse, the knowledge scattered with the smiths themselves. In southern India, by around the 3rd century BC, possibly earlier, smiths went beyond anyone. They sealed iron in clay crucibles with carbon-rich material and cooked it until it absorbed carbon and melted, producing woods, a crucible steel of stunning quality. Traded west, it was forged into the legendary watered blades of Damascus. Centuries before Europe could reliably make steel at all, India was exporting it. And China didn't just adopt iron, it leapfrogged everyone. While the West spent 2,000 years hammering spongy blooms, Chinese furnaces grew hot enough to fully melt iron and cast it, like bronze. By the 5th century BC, cast iron tools were spreading through China. By the Han Dynasty, state-run foundries employed hundreds of workers. Europe wouldn't build comparable blast furnaces for well over 1,000 years. Cheap cast iron plows and tools helped feed the empires that built the Great Wall. Same metal, different mastery, different history, which brings us to the deepest open question in this whole story. In central Nigeria, the Nok culture, famous for its haunting terracotta sculptures, was smelting iron by around 600 to 400 BC. At a site called Taruga, archaeologists found more than a dozen iron furnaces. The old assumption was that the technology must have arrived from the north, from Carthage, or up the Nile through Miro. But there's a problem. No convincing trail of evidence marks that route. And some sites in Nigeria, Niger, and Central Africa have produced radiocarbon dates so early, some claims reach back before 2000 BC that, if they hold, Africans were smelting iron before almost anyone. Those dates are fiercely contested. Critics argue ancient wood and disturbed soil layers can make a furnace look older than it is. But a growing number of archaeologists now argue the simplest reading is the boldest one, that sub-Saharan Africa invented iron smelting independently, on its own soil, with no teacher. The fight is still going on, and it's a useful reminder that this map is not finished. It's a live crime scene, and the forensics are still coming in. So here's the shape of the whole story. Bronze built the first globalized world, brilliant, connected, and so dependent on one scarce ingredient that it shattered under stress. Iron built the opposite, a world where the key material was under everyone's feet, and power flowed to whoever mastered the process. Scarce ingredient, fragile network. Abundant ingredient, unstoppable spread. If that tension sounds familiar, if it sounds like oil, or rare earths, or the chips in your phone, that's because we never stopped living in it. The Bronze Age didn't end because we ran out of bronze. It ended because the world that made bronze possible broke first. Something to keep in mind in our own age of long, thin, fragile supply chains.